Okay, hello everybody. Just my name is Azmara Ugalam. I would like to thank you such great opportunity to present our research work entitled on landslide factor optimization for landslide susceptibility modeling at Addis Ababa Adama Science and Technology University for the International Research Symposium. So, when it comes to my background, I have base in geology from Bahadar University, Bahadar, Ethiopia, and MSc Engineering Geology from Addis Ababa Science and Technology University, Addis Ababa, Ethiopia. And now I'm working as lecturer and researcher at the Department of Geology, University of Gondar, Ethiopia. So when it comes to my presentation, yes, I have introduction section, I have methods and material, result and discussion, and finally, just I'll come up with conclusion and recommendations. So when it comes to the introduction section, we know that the natural hazard particular landslides became an impediment, becomes the most destructive natural hazard and causing for damages in farmlands, infrastructure, and sometimes cause of life, which is commonly occurred in mountainous terrain when the topography is rugged. So there are different conditions and triggering factors which can aggravate the landslides in landslide prone regions. So those landslide hazard becomes an impediment for the development of both developed and undeveloped country. However, its damage is high in developing countries. As you can see here in the image, destruction of different highway and walls, and here is about the buildings, which is globally damaged by landslide incidents. We show you that landslide becomes a global challenge by destructing different infrastructure as well as cause results of as well as resulted in the death of living things. When it comes to in case of Ethiopia, the condition triggering factor are favorable. There's 40 occurrence of landslide in different parts of Ethiopia. So it's resulted in the devastation of different environment, agricultural land, roads, house, and loss of lives. As you can see here, here is different damages by landslide incidents in different parts of Ethiopia. We show you landslide became a great impact on country Ethiopia compared to the globe. So when it comes to study area which is affected by extremely harmful, extreme and anthropogenic trigger landslide incidents and cause for the loss of life as well the properties. Therefore, in order to manage this destructive natural hazard, which is really important to understand what's landslide, and it's very important to map the special distribution landslide which is called landslide susceptibility. However, the quality of this landslide susceptibility model is highly dependent on landslide factors. So, landslide factor optimization should be the first step in susceptibility modeling in order to reduce in order to increase the quality of landslide susceptibility models. So, when it comes to uh, that in that case, there are no defined standard yet to select landslide factors. However, researchers try to their own base to select landslide factors based on geoenvironmental condition and sometimes landslide type analysis. However, it is greatly depend on expert experience. In this study, just we try to adopt the receiver operating characteristic curve using to select landslide factors when the AC value is greater than 0.5. So this AC is relatively easy to apply integrated landslide factor with past landslides using combination rule in ArcGIS environment or tools. Here is the objective and research gap. Generally, the objective is to select the most suitable landslide or conditioning factors using AC method and finally produce landslide accessibility map using frequency resolution method. Research gap. According to our literature review, there is no work which is conducted on landslide factor optimization using AC methods yet now. As a result, we are inspired to work on landslide factor optimization. So its originality is related to the factor optimization using AC and land susceptibility model using statistical methods study area. Here is the location of study area, which is located in East Africa, the northern Ethiopia, in a Amhara regional state. That is, as you can see from the map. So when it comes to geology of the study area, which is bimodal, which means mafic and felsic rock composition is available, and highly weathered and slight weathered rock material is available, and even there is unconsolidated turf material, which is altered or intercalated with this basalt and felsic trachyte and rhyolite rock units. So that's when it comes to material and matrix. So in this research, we would have performed detailed literature review, field work, satellite image interpretation. Then finally, we have used frequency ratio method to develop landscape accessibility models. So here is a set of equation. Equation 1 help you to evaluate the relation between landslide parameter or landslide factor class with landslide occurrence using HCl. You can calculate using this equation. Then equation to help you to produce landslide accessibility model by sum up the frequency value multiplied by different parameters or landslide factors using raster calculator in GIS. Then finally, you will produce a single model. Then you will perform model validation using a ratio curve, that is specificity versus sensitivity versus specificity. Then from that curve, you may calculate AC. Based on AC value, you can judge whether your model is accurate or not. Here is the graph that shows you the general procedure that we use in this study. So for this, you need to have a data source and you have to collect that data. Then you may extract those data from different sources, as you can see here. Then you will extract these landslide factors as well as landslide inventory or landslide events, which can be grouped into that 20, 70%, and 30% for validation of your model. Then after you extract different parameters, you may convert into the same raster size as well as type, then you reclassify into different subclasses with natural classification method in GIS. Then you may produce landslide thematic factor maps. Then this landslide thematic maps will combine with training landslide dataset or raster. Then you will perform weight rating for each factor class. Then after that, you may perform rasterized factors and using lookup tool. Then after that, you will produce landslide accessibility map index by summing these all weighted factors using raster calculator. Then after that, you may classify it into different zones that show you from a stable region to unstable regions using a natural classification method in GIS. And finally, come up with the landslide accessibility model zones. Then after that, you may combine this landslide accessibility or predictive maps with third-party landslide data sets to produce 2 extra landslide pixels for each accessibility zone. Then finally, you may produce a RAC curve, which is sensitivity versus specificity. Then from that curve, you may produce an area under that curve, then evaluate its performance and accuracy of the model. That's all about the methods. When it comes to resulting discussion, using detailed field survey and Google Earth image satellite interpretation, we produced 700 pure landslides, which was classified into that 70% for training and 30% for validation. So among this, just 11.2% is rotational slide, and 22% is that transitional slide, and 6.7% of landslide is grouped under debris and the rockfall, and now is grouped under 29.5% in the study area. Here is a graph which shows you the relationship between landslide percent versus landslide area coverage. As you can see here, the less than 200,000 meters square is covered by 73% of landslide. However, more than 200,000 meters square area is covered by 23% of landslides, which means from this graph we can understand that A small landslide cover frequency is high, but large landslide frequency is very low. That's why this curve becomes gentle. Here is Google's imagery in the time series landslide. As you can see here, this is the mountain. At the mountain 2, that is unconsolidated soil material, which is here is a stream or seasonal river. This causes erosion of the slope material. When the slope material is eroded, this material will slide down and sometimes block the river. As you can see here, just this one is landslide in this region. Another is here. In this area, landslides occurred in 2012, as you can see here in red dot line. When we see again after 2 years, this area becomes recovered and covered by small vegetation. Again, when we see in 2018, after 4 years, this is completely covered by vegetation, but still there is landslide due to reactivation of landslide because of this river erosion is continuous. This shows the satellite image interpretation is one of the most powerful tools to evaluate the time series landslides in a certain region. So finally, we produce these maps. We show you the landslide inventory map. We show you the spatial distribution of landslide. As you can see, a red and dark dot line dots show you the landslide distribution in a steep region, as you can see here, and along streams, which means the topographic condition as well as the drainage density can control landslide occurrence in a certain region. Here is different photo which taken from the study area. Yeah? Having that, the very landslide factor, just we performed the environmental literature and landslide analysis, and we found 12 landslide factors are suitable based on our evaluation. Those are lithology, slope, aspect, curvature, distance stream, distance to dynamic stream, density, linear density, elevation relief, annual mean rainfall, and soil types. Here is the map which is produced in GIS software. Then after that, we perform landslide factor optimization. Then from that, we have got only 6 factors whose AC value is greater than 0.5, such as lithology, slope, stream density, relief, curvature, and annual mean rainfall, as you can see here from the map. So that makes we try to evaluate the relationship between factor class and landslide occurrence, as I expressed before in the next section, using equation 1. If the value is greater than 1, then landslide potential, but if it is less than 1, then landslide potential. So based on this, we produce this correlation between slope class versus frequency ratio. As you can see here, as the slope angle is increased, the factor values increase, which means the slope has a great impact on landslide occurrence in the study area. Again here, curvature. Curvature group into 2, that is flat. This is the center is flat land. Here is convex land, and here is concave related to steep slopes. Therefore, as you can see here, the FAR value, which is greater than for convex and concave lands, which means related to water ponding effect when it is convex and gravity effect when it is steep slopes. Therefore, from here we can understand that curvature has a great relationship with landslide occurrence, but when can see the flat land, there is no potential for landslide occurrence because it is stable regions. Here is another lithology relationship with landslide occurrence. As you can see here, the 1, 2, 3, 4 lithology has a FAR value greater than, lithology class has greater than 1, which means highly correlated, which is related to degree of weathering, fracturing, and the very shallow soil coverage. Here is another stream density. Stream density is one factor that can control landslide occurrence. Whenever the stream density high, this means the material is very loose. Therefore, landslide in that region will be high due to soil erosion or removal due to by riverbank erosions. So just having that, and after that, just what's next, you have landslide factor map, you have landslide invented, then combination relation with the landslide factor map. Then you have to wait the sum up all that in order to get a single landslide susceptibility map. So we do produce 2 maps, 2 models, which is for 2 landslide factor as well for 6 parameters, that is after factor optimization. Here is the map, the model. We show you the spatial distribution of landslide future occurrence in the region. The yellow color is yellow and green color is just stable region, but the deep red color is one, and light red color is characterized by high landslide prone regions. This is related to slope condition, distance to a stream or river, uncontrolled soil material, and shallow flow depths. After optimization is also same, but the difference area coverage. As you can see here, the area coverage of this landslide susceptibility class. As you can see here, the red color, which is after optimization, the blue color is just before optimization. So as you can see here, when we optimize the factors, the area coverage by very high and high is reduced, but increased by low and very low, which means the model accuracy becomes increased. Then after that, model validations. We perform the using receiver operating character and AC to validate the performance and accuracy of the models. As you can see here, the graph, which is a racing curve, which is plotted in the y-axis that is true positive rate, that means observed landslide, and the x-axis that is false positive, which means predicted landslide. If the general principle here, if this graph or this curve is close to the y-axis, which means your model is accurate, but if it is deviated to that, your model is inaccurate. In general, the value of AC is very important to evaluate whether your model is accurate or not. This value range from 0 to 1. If it is close to 1, your model is accurate, but if it is close to 0, your model is inaccurate. If it is 0.5, that is the cut point, that is your model is random. So based on AC, in order to evaluate whether factor can control the quality of landslide susceptibility or not, look here. This is a graph before optimizing. As you can see here closely, the AC value, which is 66.41 by 69. Yeah. When you see here, that is 73 by 17. There is a difference after optimization, which means landslide factor optimization can increase your model quality. From this, we can understand from this graph. We come to the conclusion and recommendation section. So as we discussed before, AC value a greater than 0.5 factors produce a good accuracy model, but all parameters before factorization relatively low quality models. Therefore, landslide factor selection is very important to increase the model quality. So, researchers should evaluate the suitability of landslide factors using AC method or other methods to produce high quality model before they are going to produce landslide susceptibility models. This finding will be used as a guideline for researcher and decision maker in landslide factor selection and land use planning, as well mitigation strategies. This is all what I have to say in this presentation. Just I would like to thank you for your undivided attention. Any suggestion, any comment, you are welcome in subscription. Thank you.